Next question. Digital connectivity where OT meets IT. How do I address the risks and challenges from a security perspective?
Well, Jonathan, I just want to let's step back a little bit and take a look around OT. OT is typically associated with heavy industry, manufacturing, and energy. It's defined as the technology that interfaces with the physical world and includes industrial control systems, SCADA systems, distributed control systems. We often hear about HMI and PLCs. It's old-fashioned technology designed to be in a closed network as against connected to the internet. Some famous or well-known attacks on OT would be the Stuxnet worm, albeit 10 years ago now, I think it is, where allegedly the Israelis and US came together and attacked the Iranian nuclear program. An example, perhaps moving forward in a few years, of where OT meets IoT is traffic light management systems and autonomous vehicles. When autonomous vehicles approach a junction at 4 a.m. and they have the ability to change a red traffic light green to continue on its journey. This is what we're looking at in the future. So what's driving the change around OT connectivity is very short. Improved productivity, improved performance, business processes, greater efficiencies for the business, but also greater customer experience. If we look back to the traffic light management system I'm talking about, autonomous vehicles traveling a fixed route in food distribution to deliver at 4 a.m. and they turn a red light green and they continue on their journey. Imagine the positive impact that's going to have on food distribution. But what if the traffic light management system was compromised, or what if the autonomous vehicle is compromised? So these are risks versus rewards. 10 years ago, IoT was a concept. We spoke about, connected devices. We have billions upon billions of connected devices. I have a laptop here, I have a mobile device, I have a PlayStation, I've got Bluetooth headset, I've got another one here on me. And this is just in this room here, so it's everywhere. And it's evolved significantly in retail and in manufacturing in recent years. Developments in this technology for the consumer's benefit has driven the speed by manufacturers, speed of development, but they haven't always focused on the security, and that unfortunately hasn't developed as well as the product has. In January of this year, the UK body released results of a consultation period. One of the key findings was that industry-wide, there is a real desire for legislation around all of these connected devices. And of course, we've got global standards body with ETSI and who published their standards. But it is important that we have a standard that everybody understands and complies with. If we look at OT in a retail environment and say a glass manufacturing, taking a reading from thermostats. What if a thermostat is compromised in the frozen food section of a supermarket? We've got wasted food coming into the store in the morning, and multiply that by tens of thousands of stores, and you can see the impact. If there's a glass furnace running at 1400 degrees Celsius, and that thermostat is compromised, are we looking at an explosion? Are we looking at a more subtle change in temperature which could compromise, say, glass quality, impacting supply chain and food consumption? So traditionally, OT was about safety, reliability, and availability. And IT is concerned about CIA, confidentiality, integrity, and availability. People tend not to die if something goes wrong in IT, but it's a very different scenario in the OT world. Deploying security to an OT environment can be a real challenge, commonly deployed on legacy systems. We've got agents that are not compatible, security agents that are not compatible. We don't have enough memory with the devices that are there. And often the warranty from vendors is voided if the OS is interfered with in any way. And that's probably one of the most prevalent challenges. But what I'd like to discuss briefly, just 4 key areas that you can address in reducing the IoT and OT security threats across your enterprise. First of all, we've got to discover and catalog all of the IoT devices in our network. Okay, we can't protect what we can't see. So profiling all of our devices with the security team gives you much needed visibility into the unmanaged assets. Remember, these are typically unmanaged assets. The exact number of network connected IoT devices and their underlying operating system, risk profile, and the behavior when interacting with other connected devices. And this is bringing more of the AI ML into play to help us along that. Patching, easily patchable IoT devices. So There are IoT devices out there that can take patches, but unpatched vulnerabilities put your organization's security and data at risk. Many IoT devices run on legacy OS, as I said, and they no longer offer security updates. So with devices discovered, we can easily manage that problem by investigating the security posture of the top, say, 2 or 3 devices, like printers, cameras, and so on, and establish a patch and management and firmware upgrade strategy around that. The third area I would look at is segmenting IoT devices within VLANs. So if you implement a micro-segmentation in your network, and you've got firewall policies to isolate IoT devices from your IT devices, you're reducing your risk, especially for the unpatched devices. Maybe base your segmentation strategy on device type, threat levels, usage patterns, device profile characteristics, and then segment maybe by security level. So doing this is going to create a strong perimeter defense. It's going to contract the attack surface and restrain the lateral movement of any exploits. And the last one is enabling active monitoring in real time. So traditional endpoint detection response requires software agents. I mentioned earlier on that sometimes they're ineffective because you can't load the agents onto these devices. They're not designed to take agents. So instead, maybe implement a monitoring solution that continuously analyzes the behavior of your network connected devices. And in real time, stopping the threats for devices, even if they are segmented, and formulating the baseline of what is considered normal behavior helps to monitor for that anomalous behavior. So it gives you greater visibility. So if in conclusion, if we're looking, OT now moves into the IT world, becoming part of the IoT ecosystem. People refer to it as OT or IoT. It's all the one. Key recommendations for the strong security posture around the OT IoT environment: discover and catalog, patch where it's patchable, network segmentation, active real-time monitoring. I'd love to talk more about it. Thanks very much for your time.